Motion in vertical circle. Motion in vertical circle. Motion of a body in vertical circle. Let us imagine a stone of mass m is tied at the end of a string of length r and rotated in a vertical circular path. Let us imagine that a stone of mass m is rotated by tying it at the end of a string of length r in a vertical circle. Let us imagine the stone is rotated in a vertical circle of radius r. Then let us suppose the bottommost point of the circle is A, topmost point is B, and the point in the horizontal line passing through the center is say C. The velocity at bottommost point is V1, at the topmost point is V2, at the horizontal position is V3. V represents velocity. Mg represents the weight. Mv square by r represents centrifugal force. T represents tension. The symbols used here are V is velocity, Mg is weight, Mv square by r is centrifugal force, and T is tension. At A, Mg acts downward direction, Mg acts in the downward direction, Mv1 square by r acts in the downward direction, and tension T acts in the upward direction. At A, Mg is down, Mv square by r is down, and T is up. T1 is up. So, T1 is in the upward direction, Mg is in the downward direction, Mv1 square by r is in the downward direction. This is at A. At B, Mg is downwards, T2 is downwards, and Mv2 square by r is in the upward direction. So at B, Mv2 square by r is in the upward direction, Mg is in the downward direction, T2 is in the downward direction. At C, Mg is downwards, T3 is towards the center, and Mv3 square by r is outwards from the center. T3 is towards the center, Mv3 square by r is outwards. Mg is downwards. Mg is constant. V decreases as the body moves up. So, Mv1 square by r is greater than Mv3 square by r is greater than Mv2 square by r. T decreases as the body moves up. V decreases and Mv1 square by r is greater than Mv3 square by r is greater than Mv2 square by r. And T decreases as the body moves up. When the body is in vertical circular motion, it will be in equilibrium state. It will be in a equilibrium state at A, at B, and at C. At A, at B, and at C. At A, Mg plus Mv1 square by r is T1. At A, Mg plus Mv1 square by r is T1. At B, Mg plus T2 is equal to Mv2 square by r. Mg plus T2 is equal to Mv2 square by r. At C, Mv3 square by r is T3. The relations between tensions and forces is at A, Mg plus Mv1 square by r is T1. At B, Mg plus T2 is equal to Mv2 square by r. At C, Mv3 square by r is equal to T3. These are the relations between forces at A, B, and C. Condition for completing vertical circular path. Condition for completing vertical circular path. If at the highest point Mv2 square by r is less than Mg, if Mv2 square by r is less than Mg, the body cannot reach the highest position B. Before reaching the point B, it leaves the circular path. If Mv2 square by r is greater than Mg, then only a tension will be created in the string in the downward direction. If Mv2 square by r is greater than Mg, then only tension will be created. And the body moves in circular path, of course. The minimum velocity required for completing the circular path is when Mv2 square by r is equal to Mg. When Mv2 square by r is equal to Mg, the body will not leave the circular path and the tension will be 0 at this position. Hence, the tension will be 0 and For just completion of the circular path, mv2 square by r must be equal to mg. Hence, v2 square is equal to rg. Gets cancelled. v2 square is equal to rg and v2 is equal to root rg. v2 is equal to root rg. This is the relation for completion of vertical circular path. For completion of vertical circular path, v2 should be equal to root rg. That is, a body should possess the velocity root rg at the highest point in order that it may complete a vertical circular path. To complete the vertical circular path, a particle must have the velocity root rg at the highest point. To have the velocity root rg at the highest point, with what velocity should the body be projected at A? What should be the velocity at A so that the velocity at B is root rg? To find this, first let us consider the energies of the body. At A, the stone possesses kinetic energy only. Its potential energy is 0 and its kinetic energy is half mv1 square. Its velocity is say v1 at A, hence its kinetic energy is half mv1 square. At B, it has both potential and kinetic energy. The potential energy is mg into 2h because the distance AB, height AB is equal to 2h or 2r. Hence, it is potential energy is equal to 2mgh. Kinetic energy is equal to half mv2 square. Kinetic energy is equal to half mv2 square. By applying conservation of energy, we get the relation half mv1 square is equal to 2mgh plus half mv2 square. 2mgh plus half mv2 square. From conservation of energy, half mv1 square is equal to 2mgh plus half mv2 square. From the conservation of energy, half mv1 square is equal to 2mgh plus half mv2 square. From this relation, m gets cancelled and rearranging we will get v1 square is equal to 4gh plus v2 square. 4gh plus v2 square. v2 square is the square of the velocity at the highest point. v2 is equal to root rg. The minimum velocity at the highest point should be root rg. Hence, v2 is equal to root rg. v square is gh. v square is equal to rg. Instead of r, I have used here h. Hence, we will get v2 square is equal to gh. v2 square is equal to gh. So, v1 square is equal to 4gh plus gh. So, v1 is equal to root 5gh. Root 5gh. If the radius of the circle is taken as r, then v1 becomes root 5rg. Root 5rg. So, at the bottommost point, the velocity should be root 5rg in order that the velocity at the highest point is root rg. So, the body should be projected with the velocity root 5rg at the bottommost point of the circle in order that it just completes the vertical circular path. To complete the vertical circular path, the minimum velocity at the bottommost point must be root 5rg.